everybody, welcome back to another Tuesday's Tech Talk with me, Danny Richie. Appreciate everybody dropping in each week. Thank you very much. And this week we're going to be talking about open baffle speakers and what the allure is of the open baffle speaker. We're also going to look a little bit about the drivers that are used and talk about whether or not special drivers are required for open baffle use. We're going to look at the baffle shape and how that affects the response. We're going to look at some H-frame designs, W-frame designs, flat baffles, U-shape, V-shape baffles, and we're going to kind of compare those. We're also going to look at the response of a little M130 driver on a flat baffle and in a box design. Same exact driver, same measurement, just a different box, and let's look at what happens to the response. That's going to be a little bit interesting. And then let's look at these speakers that are next to me here, the Exoticas, and talk a little bit about those because I at least have to share something really cool with you during the episode. So, open baffle speakers. What is the allure of open baffle speakers? I know when you hear a lot of people talk about them, you hear people talking about how much more transparent they are, how much more open they sound. They do away with that box sound that you get when you put a woofer in or a driver in a box. That boxiness goes away. There's an openness. There's also a difference in the way that it loads the room. When you have a typical woofer in a box, as that woofer moves, it changes the pressure in the box. It also changes the air pressure in the room. So you're putting positive and negative air pressure in the room versus what's going on in the box. And that can load the room up with compression or with the pressure changes in the room. The room will tend to want to expand and contract along with that. A lot of people have noticed whenever you hit a room with a big bass note, that bass note tend to pressurize the room. You'll get what's called room boom behind the bass note. So you'll get that impact of the hit and then the of the room cascading back from that hit as it's recovering from that pressure. Open baffle speakers work a little bit differently. They can still give you that punch, but it's moving air from one side of the room to the other side of the room real quickly. It's not changing the pressure of the room so much, so you're not getting that room boom. Also at 90 degrees off axis, you're getting a cancellation effect. So you're kind of getting a figure 8 wave front. You're getting output to the front, you're getting output to the rear, but you're getting a cancellation at the sides. And that can help minimize some of that room interaction. Minimizes that room boom. Again, like I said, you're getting that pressure from one side to the other. You can get a quick hit, a quick response, but without some of the boominess. Let's talk about drivers. Are drivers specific for open baffle? Yes, they can be, especially when you go into lowest frequency ranges or lower frequency ranges. If you're using something like a little M130 here and you're limiting the frequency response to ranges that are above 200 hertz, you can have a low pass filter on that, or I'm sorry, you can have a high pass filter on it, and that will remove the lows from the signal, and that will limit the excursion of the drivers, and it takes away the need for the compliance to control the driver because you're just physically not letting it play down very low. What do I mean by compliance of the driver? You know, we're looking at drivers for an open baffle, ideally around a 0.7 QTS range. That's ideal for open baffle. What does that mean? Well, the compliance is made up of a couple of things. It's made up of the spider, which is this element here. It's a diaphragm connected to the voice coil former. And then there's the surround that's connected to the cone. And those two things and the stiffness of those is kind of what controls the movement of the cone. Now a high Q driver can rely just on the stiffness of the compliance to control it without anything else affecting it. A lower Q driver needs, in addition to what the suspension's doing, it needs the air pressure in the box to help control the driver. So you've got positive and negative air pressures that are going on in the box, and as the woofer moves forward, it's putting a negative air pressure in the box that's pulling back against the cone. As it goes in, it's creating positive pressure in the box that's pushing against the cone. That's part of the compliance. That's part of what it needs in order to function properly. Otherwise, low bass notes will just beat it up. But a higher Q driver is designed so that you can send some of those lower frequency notes to it, and it just relies on the suspension alone to control things. So when you're using open baffle speakers, you're looking at speakers for open baffle, especially if you're looking at something that's got to play down very low, well then you'll want to look at higher Q drivers. The other thing we're going to talk about is the effect that the response has, the effect that the baffle has on the response when you put it in an open baffle. When you take the little M130 driver and you put it in a sealed or ported box, you're going to get a roll-off that's fairly linear, and then at about 700 hertz, it's going to start dropping off where you've got baffle step loss. That's in a baffle that's about 8 inches in diameter, which is about what this would need, 7.5 to 8 inch diameter wide baffle. So you're going to have step loss below that. If you put it in an 8 inch wide baffle that's an open baffle, what you're going to get is you're going to get output from the back and output from the front, and at some frequency ranges they're going to couple, and in other frequency ranges they're going to cancel each other out. Let's think about the higher frequency ranges where the output is just going to come straight out of the cone. It means it's going to play forward only. Then as frequency decreases, it starts becoming more omni, and it can even wrap around and go to the back. And at one point you've got output from the front that's wrapping around toward the back, but you also have output from the back that's wrapping around the baffle and trying to come forward. And at one point those can be in phase with each other and cause a peak in the response. We get what's called a dipole peak. In this case it would be about 1 kHz. You'll see a big peak in the response, and then below that you'll have no output. It'll just drop off drastically below that because you've got front wave and back wave just canceling each other out. I'll have Ron throw up a JPEG image of the frequency response from the little M130, and you can see the difference in the response from a box design versus an open baffle design. Go ahead and throw that up for the guys, Ron. So you've got a dipole peak there, and you've got it in a place where it makes the response uneven because it's peaked high in one range at 1 kHz. So how do you fix it? Well, you could go in and try electronically or with a filter try and pull that peak out of it. The problem with that is you're inserting a lot into the path to correct it, and you're still not doing anything about what's going on below it. You still have nothing going on down below. What a lot of guys will do is they'll start increasing the width of the baffle and making the baffle wider and wider. As the baffle gets wider, it'll shift that peak down in amplitude. It won't be as high, and it'll shift it lower down in frequency range where it's starting to roll off. And if you put it on a wide enough baffle, you can shift that peak down to where it's completely flat, and it's actually lifting down there where the frequency response had already started to roll off. So you can kind of get a nice smooth response out of it by increasing the width of the baffle. However, there's penalties that come with that. When the baffle gets real wide, you're doing away with all the advantages that you would get by going to an open baffle design. An open baffle design tends to be more transparent because it doesn't have a box sound. Now you're creating a whole wall that the speaker's mounted to, and you've added a lot of surface reflection. So all of that surface reflection then tends to make the output of the speaker sound like it's playing as if it's all coming from the wall, and it really changes how the speaker sounds. You might as well just taken the driver and mounted it in a wall, because you've done away with all the advantages that you're trying to accomplish by going to an open baffle design. So how do you separate the front wave from the back wave and not do that? Well, one of the ways is like we've done here on the N-Exotica. We've got minimal amount of surface area on the front, and we use side wings in order to separate the front wave from the back wave. Now when you go to a low frequency range, like these lower drivers in the bottom of the speaker, they're only covering a low frequency range. So you can use different types of baffles to increase those lower frequency ranges. Like we typically like using H frames or W frames with our servo subs, and that frame on either side, we call it an H frame. Let's consider the baffle is here, and you have a side panel on each side. So if you looked at it vertically or from the ends, it would be an H. So you got a side on each side, or a panel on each side. Same thing with a W, just the W is just angling them a little bit in the same thing. The other option is to do a U shape or V shape. That keeps the driver still mounted on the same surface, and it just puts the sides just to the back only. And there are advantages and disadvantages in doing that. So let's look at the Exotica for a moment. Lower frequency range is kind of a wedge shape or V shape low frequency drivers. They're not playing up very high. They're only playing up to about 160 hertz or so, where they're crossing to the NQ drivers. So the wedge shape design works great. It loads the drivers. It gives a great separation of the front wave to the back wave. It allows it to roll off really low and have really solid output down to a low frequency range. But now as frequency increases and the wavelengths become shorter, you can't put the drivers in a complete U-shape or V-shaped wedge. As you see here, you see the back of the speaker, you see that it's got a long wing on one side, but it's got a short wing on the other side, and it's even got a scalloped out area as it passes by the tweeter. The reason being is if you wedge shape the whole thing, it's playing up into a frequency range where it will set up a cavity resonance within that space, and it will sound really bad. You don't want to create a cavity resonance. That's going to scream at you and bark at you. You can't do that. Once you get into higher frequency ranges, you can't wall the sound in. You can go to an L shape or an L shape with a short wing, and you can work with the lengths of those wings to control the roll off at the low end. And you can actually create a flat response by proper calculation of the long wing versus the short wing. Works out really well that way. Works out great for the Exotica. The upper drivers here, the NQ drivers, cross it around 160 to the lower drivers, and then it crosses to the planar magnetic tweeter that's in a waveguide. Think of it as when you're listening to, say, the hit of a cymbal. You hear the hit of a cymbal, the tweeter's covering a lot of that range, and it radiates forward and backward into the room, much like the sound of a real cymbal. When you strike a real cymbal, it radiates 360 degrees around. This does very similar to that, but it's canceling at the sidewalls. So you have the advantage of the cancellation of the sidewalls, but you have that openness, that transparency that you get just as if the instrument were really here. And it really helps recreate a three-dimensional sound field. Now, what are the limitations? What are the cons to Open Baffle? One is you can't hook it up next to the wall or set it next to the wall like these are just sitting here just for looks. You can't play them that way. The reflection the output from the rear drivers will reflect off the wall and come forward with the forward projecting output, and it'll sound like a time smear of that signal. It'll just be a bit of a blur, as if you added reverb to the signal. You don't want that quick reflection off the wall. You want a delay. You want about a 6 millisecond or more delay. That way your ear perceives it as a late arrival and a reflection, not part of the on-axis response as a smear. So how far do you have to bring the speaker out from the front wall to gain a 6 millisecond or longer delay? About 3 feet or more. That means 3 feet from where the drivers are. From the drivers to the wall, 3 feet is a minimal. The further the better. The further you get them out into the room, the deeper the soundstage is going to be, the more open it's going to be, the more transparent it's going to be. So with any open baffle speaker, it doesn't matter what brand it is, what it is, you have to pull them further out into the room. You can't set them against a wall. That's just the physics of it. Those are the basics that I wanted to cover. If you guys have questions about open baffle speakers, you're going to hear more about some of the things that we do, put them in the comments section. And that's all for this week, and see you guys next week. Thanks.